everybody. Like to say it's nice to see you, but I can only see you on video screen, so I'm sure you're nice anyway. But my name is Brian Hankin. I have been in the business of battery monitoring for 30 years, conceived and developed a system called CELLWATCH, and I'm chair of IEEE 1491 working group, which is a IEEE paper for battery, which covers battery monitoring and the uses and whys and wherefores of how to apply monitoring. What I thought I'd do today would be to show you basically what the end user sees, right? So, I spend a lot of time talking about, pieces of hardware like you see behind me in battery sites. This particular product, as I said, has been produced for the last 25 years, 30 years, and reliability is kind of a given. We are, and ESL is a global company. We have 3 offices around the world: Europe and China, and here in the US. And we just about deal with every major client who has batteries, and can save them a lot of heartache and time and money with their battery asset. And basically our mission is to prevent unplanned outages and allow users to get the best and the most from their battery asset, which can be a big, obviously be a big expense. Hopefully you see what we call CELLWATCH Central, which is the focal point of the hardware that you see behind me. And basically, so I'm going to start at this end and work the other way. So basically what you can have here is sites that are around the world, basically around the US, around the state or the county, and be able to see what is going on those sites individually, set alarms, get reports for them, and allow you to basically, if you have a lot of batteries dispersed, allow you to be able to get a real handle on what is going on with the batteries, whether you need to send somebody or not. Is it a routine visit? If it's a routine, you may not need to go because everything's fine. So you can see that it can save a lot in truck roll time and money as well. So hopefully here on the system you see you see a map of the US. Obviously we can change the view of that, put terrain in, those kind of things. Some of these sites are not active at the moment. Some of them have network issues, and you can see on this one here, the Dallas one here. We'll go to Austin and Hall 2, and show you what Hall 2 looks like. There we go. So you can see that we can see remotely all the details in a battery site. So we can see, ohmic values, what the alarms have been, when they ended, what the duration was. You can get reports for that actually from the site itself. In fact, you can download files from that site. So if you want to download a history file for that to see what's been going on over a period of time, you can do that. Discharge files, you can actually take a look at a discharge file. Takes a little while because I'm on the VPN here. Never mind, the perils of doing stuff live. You can also control, so you can actually stop, start, make it scan the batteries that are at a particular site if you want to reconfirm information on it, and set alarms for that individual site as well. You can obviously set up different groups. So here we have administrators groups, technicians, and viewers, and the permissions for those can be set up so that, for instance, administrators can do system settings, control the battery monitoring system. technicians can just do the control part, and then obviously viewers, you may have staff online that you don't want them to tamper with anything, but just to be able to view it, so you can actually set those permissions. We can actually also set up individual alert profiles so that you know, a prolonged alarm for a certain length of time notifies a certain person with a certain email address. So, you know, things like, you know, high temperature, you may not want to be woken up at 2 o'clock in the morning for, whereas, you know, if there's a discharge at a particular place or power outage at a particular place, you may want to know about that, or someone may want to know about that. And all these alarms can be directed to the relevant people. So really, Frontier is probably the most effective battery monitoring system for remote sites available on the market today. I can now show you, I think, what the system looks like if you're actually at one particular site. So the Frontier device itself basically shows you what the system is like, shows you the voltages here. We have ohmic values. The hardware is completely NERC compliant, so we can also measure interstrap ohmic values as well. So we can measure the actual strap value between the cells and the jars. And we also have the ability to do electrolyte levels as well. So it's a fully comprehensive system. The majority of it, the units that you see on the back wall behind me, are the basis and the core of the system. The Frontier device itself is really modeled around remote applications. We have a bigger system called CELLWATCH, which is just solely for, primarily for UPS systems where there's a high volume of batteries and therefore a high volume of hardware. So I guess the difference between the two is Frontier actually looks at dispersed, perhaps smaller batteries. CELLWATCH looks at the same number or more batteries, but usually in 1 or 2 rooms. So it's a slightly different application. The core of the system itself is basically tested, proven, and very effective. And as you can see, we can measure intercell strap ohmic values, which are pretty small values in that respect. So, you know, usually we're finding whether a battery has been torqued up correctly and those kind of things on there. So looking at this then, again, we see the alarm log. So we have a history of what the alarms were, low voltages, what the value was, the duration it was there for, whether it was acknowledged or whether it just ended, and those kind of things. So you have a history of alarms there, and you'll see down the bottom, we can export that as a CSV file if you need that as a document. If I go to history, you'll see that in history, we can select which historical data. So if we want to look at a discharge file, we look at what the discharge files have been. So this is when the system goes into operation and the batteries are actually running on battery. You can see that, oh, there we are. If we plot that, we can actually plot it there. We can also download this data through the CELLWATCH Central, which I showed you earlier. And there we go. So this is a very brief 33-second discharge, but it actually shows the performance of the cells. And if any cell falls out, they usually can fall out in quite a short time. And you know, over the course of a string of batteries, you may not be able to see it. It may just look like a small voltage drop of 2 volts in a voltage that's dropping anyway, so it's very difficult to detect. If you look at them individually, then you can see them drop out quite easily. So discharge files are very useful for that. The rest of the time, the system is monitoring daily for voltages, temperatures, if applicable. We can do temperatures, individual temperatures too, and ohmic value which of course climbs as the batteries get older. So this really allows you to, again, back to our mission statement, to prevent unplanned outages, but also to allow users to get the best from batteries, so that you are not changing it. You don't have to change batteries out on a time-based interval. You can actually change batteries out when you think they're ready to go, when you are noticing that you're getting perhaps faulty batteries more regularly. Then in the meantime, you still have your uptime, and you still maintain that integrity, which obviously is very important. Very important in this industry, obviously, for maintaining communications, UPS industry, for uptime and not having any computers crash and those kind of things. So reports, of course, you can get battery reports as well. And again, this is from this system, it might be down the road, or it might be in Singapore, or it might be Northern California. So we're generating a report right now, and you'll see that we have a lot of information at the top about the system, which is, a lot of that is put in at the start. And then we have basically a full gambit of string measurements, temperature probe measurements, all the individual ohmic values, what the limits are, and they can be set individually for individual jars. And we have an easy way to do that also as well, which is a kind of a one button press way to do it. Cell voltages and temperatures, and of course electrolyte levels. And even the electrolyte levels have different warning stages. Sometimes a level sensor may fall off the battery, and the system will warn you that it looks like a sensor is not attached to the battery. Believe it or not, electrolyte level sensing is a lot more complex than you would perhaps think. And further down at the bottom here, we have just basically the serial numbers of the hardware that's in that system, just in case they need that or the client needs that for an engineer, for instance. So those reports, again, we can download as a CSV or HTML. And then we go to settings. You can see there's a whole lot of settings. You'll be pleased to know I'm not going to go through all of these. Battery design and battery profiles, they actually relate to a lot of these applications. Obviously are great because they're in an air-conditioned environment. Some, however, are not, and a big temperature change can actually make, a 10-degree change in temperature can make a 10 or 20% difference in a measurement of this small nature. So what we have is a patented temperature compensation algorithm, and we basically profile the batteries that we use when we use on that kind of thing. So that's something we can do. It's not a general thing, but it is something we can do. General settings, again, just the simple stuff on there. We can actually, if I go to diagnostics, I can actually show you the kind of things that you can do remotely. If you want to investigate things a little further, obviously you can restart the device with the large red button there. We can get individual DCM data. DCM stands for data collection module. We can ping particular channels. We can make it do manual scans. We can test hardware relays. So there are relays in the device at the site that you can basically set up for what you want and to close or open under preset conditions. And you can actually test those remotely. We can get physical current readings. We can test the fiber optic loop. This system actually works. These modules that you see behind me are they're completely individual and working from the battery that they're monitoring, and they actually use a fiber optic, polymer fiber optic, which makes the system very noise immune. and very robust, and just it really simplifies the system. And again, electrolyte levels, log files, and those kind of things. So there's a lot of things you can do with the individual device. As I say, this is the actual device itself. These are the fiber in and outs for each one. So every system we have, however large, however small, has these. So you know, you only need one on the shelf as a spare, because each one is going to replace the other if required. So it's you don't have to get different serial numbers. They work out, they readdress themselves. And the Frontier device itself is again, you know, black box, small. We have this version, and we also have a 1U high rack mount version, which is popular also. So there we have it. Basically, it's an accurate system. As I say, obviously we think it's one of the best systems out there. Don't know of another system that can actually monitor remote batteries globally, or you know, countywide, basically. So that's the system. Love to talk to you about it if you have the opportunity. I'll be in the auditorium, is it? Or the
meeting room.
The meeting room. That's right. We're going to
have you move over there and take any more direct responses. Is a great place to meet up. So again, thank you very much for your time. Great.
All right. Thank you, Jim. Thank you, everybody. And thank you to 2020 California APCO for putting this on.
We're doing what we can, so we appreciate it. Trying to keep
Good
everybody
stuff.
informed.
Thank you.
All right, so we're going to move right into our next presentation. That's going to be IT for Nature. Is IT for Nature presenter available? Who would that be? Well, we might have some time. So Lee, are you the IT for Nature presenter?
No, I'm not. I'm
saw your microphone off.
Is my mic off? No, I'm not the presenter. Actually, Terry, the